And thank you. And listen, welcome everyone. So Barbara Ryan, I'm Executive Director of the World Geospatial Industry Council. And I just would like to thank you, the participants, for joining this session. I'd like to thank our strategic partners. We've got a panel of those right after the introduction of the report. Obviously, I'd like to thank ConnectEye for partnering with us on this, and the industrial partners who have helped put this event on. So thank you very much. Let's see, let's go to the next slide, because what I am going to do is not talk too long, but I do want to give you a little brief on WGIC. You'll then hear about our policy development and advocacy work from Arnout, Desmet, the chair of our policy committee, and also executive vice president for maps and global sourcing out of TomTom. We'll do a deep dive on the WGIC Spatial Digital Twin report. We'll go into our partners' perspectives, and then you're going to see the whole second half of the event on featured company perspectives. And of course, I could have added a fifth bullet here, which would be the networking event. So that's a glance over the next hour and a half or 2 hours of your time. And again, thank you for joining us. Next slide. So WGIC is the first global not-for-profit trade association of private sector companies working in the geospatial ecosystem. And I want to draw attention to this because there are some wonderful examples of regional associations, ERSC, European Association of Remote Sensing Companies in Europe, or MAPS in the United States, AGI, one of our partners here today in India. But this is the first time that we've come together to create an opportunity for those working in the geospatial and Earth observations sectors to join a trade association that does advocacy on their behalf. And next slide will show our three key objectives or goals. And clearly, it's to strengthen the contributions of this entire industry to both society and the global economy. It's to advance global policy matters, one of which we're doing today on spatial digital twins. And as a trade association, clearly we want to create business opportunities, additional business opportunities for those in the geospatial industry. So that's WGIC and our strategic objectives. Next slide. What you will see as we do a deeper dive into this report on spatial digital twins, we really want to thank the contributors to that report. Clearly, the subject matter experts, and there were more than 60 of them, both inside and outside WGIC, members of the WGIC Policy Committee. You'll hear more about that from Arnout, but that was largely the steering committee for the entire effort, our partner organizations. And last but not least is Thomas Werner, who led the entire research and report writing effort with IGS out of Melbourne, Australia. And of course, you'll be hearing from Thomas to do the entire brief on the report. Next slide. I guess what I would just like to say in kind of wrapping up this introductory section is for all of you who have worked in the digital twin arena, it has been the purview of the manufacturing environment for decades. And so we've kind of coined this about really moving from the factory to the streets, because as our industry, our partners, and governments who are interested in this are, in fact, leveraging the spatial components of these digital twins, it is in fact moving to our geographic environment. Advances in technology, reduction in costs, there clearly a lot of interest of late has been in this area. You'll see numbers here for almost a $13 billion revenue for digital twins, 8 of which is targeted at the geospatial industry, projected to rise 45 billion. That's for all of digital twins by 2026, with an increase of up to 25 billion projected for the geospatial industry. So clearly there are opportunities there. But what you're also going to hear later on in the report is that doesn't come without its challenges. And Thomas will also be identifying some of those in his presentation. Next slide. And it's at this point that I will turn the stage over to Arnout Desmet, again, Vice President, Maps and Global Sourcing at TomTom and Chair of the WGIC Policy Committee. Thank you, Arnout.
Thank you, Barbara. So thanks for having me, and welcome also on behalf of the Policy Committee to all the attendees of this webinar. So as mentioned by Barbara, one of the pillars of the WGIC mission is to advance policy matters, especially policies that have an impact in one way or another on the geospatial industry. Next slide, please. So the Policy Committee consists of representatives of a variety of the WGIC membership. And these members cover a wide range of geospatial industry segments, as you can see, also different geospatial technology areas. And this is the current composition of the Policy Committee here. So we have representatives of Maxar, Planet, Spatial Vision, Regal, Oracle, and TomTom. It's a really fantastic group of very dedicated and very passionate professionals. And we meet about once per month. And as mentioned by Barb, the Policy Committee also acts as the steerco for this study, for this research. Next slide, please. So every year, the Policy Committee selects a very specific team for policy research. So our first policy report already some 2 years back did focus, for example, on the importance of privacy and the protection of personal information in the geospatial industry, a very hot topic at that time and to date. So this document summarizes the various policy initiatives that are taken across the globe around data protection, and it also provides specific recommendations to policymakers and the geospatial industry at large on data protection. Last year, for example, we did select the application of artificial intelligence and machine learning in geospatial as a focus theme. We also organized a number of webinars both for members as well as public webinars to socialize the findings of this research and also further promote the recommendations of the study. As mentioned by Barb, all studies that we do involve representatives of and subject matter experts drawn both from the WGIC membership, but also from the geospatial industry at large. So you can find all the reports that we published so far on the WGIC website. I definitely encourage you to download these and read these when you have time, as they contain quite a wealth of information on the specific subjects. And also, and that's quite important, certainly also for the industry as well as for policymakers, it also includes quite some specific practical recommendations. Next slide, please. So Barb did already refer to the value proposition of spatial digital twins and also the related business opportunities. So the spatial component specifically, if that's added to digital twins, that actually opens a wide array of new technical and business opportunities and use cases. And just looking specifically at the domain I'm working in, at TomTom, we develop, for instance, detailed high definition maps. And without a spatial element of geolocation and without that high spatial relative accuracy, these maps would only facilitate a very limited number of use cases. Use cases such as visualization or basic design, planning and monitoring. But it's only by adding the high absolute and relative positional accuracy to these maps that you enable a very advanced use case, such as highly automated and autonomous driving, efficient road safety modeling, road design, etc. So the spatial element, the addition of that spatial element is absolutely key to bridge that physical and digital world and also provide the necessary context to drive advanced use cases. Next slide, please. So looking at the increased investments in digital twins and also the growing abundance of new sensor data, new geospatial sources that we unheard about 10 years ago, the policy committee decided that it was important and the right time to focus its research team on spatial digital twins. So we did contract Thomas Werner from Integris Group Services as a consultant to drive the research and write the policy report. But as already mentioned, the policy report draws from the experiences and the knowledge of the combined knowledge of a lot of members and subject matter experts across the industry. We did also request Thomas to look specifically into past experiences, both successes as well as pitfalls from other digitization approaches, such as building information modeling, BIM, product lifecycle management, PLM, in order to learn from these experiences and integrate these in the recommendations for the spatial digital twin domain. Next slide, please. So it is, of course, when we talk about spatial digital twins, it's very important to clarify terminology and definitions. And the report contains a concise section on to develop the definition and clarify the concept of spatial digital twins. It also introduces the micro, meso, micro level in its application. And integration is a highly complex but critical requirement if we want to really fully unlock the power of combining digital twins at these different levels of granularity and detail. So the spatial dimension is an essential enabler for such integration. Another area that's very important, another dimension that's very important is interoperability. And Thomas will definitely tell you more about that as well. There is a lot of talk about the metaverse recently. The metaverse as a shared virtual environment that people access via the internet or online. So late last year, Facebook, Meta now, did socialize the concept of the metaverse and announced plans to create tens of thousands of jobs, high skill jobs, to help shape that metaverse. So it's really a very hot topic at the moment. As the metaverse grows, it should create online spaces where user interactions can happen in a much more multidimensional way, where people, instead of just viewing digital content, can actually interact with that content. So it's a very important topic, but it's also very important to, in the terminology, to make the clear distinction between a digital twin and metaverse. But as the physical world evolves over time, so does also the digital twin. So we also add that fourth dimension, or the temporal dimension, to digital twins as well. Next slide, please. So we did request IGS to integrate specific focus discussions with subject matter experts and research on standardization and interoperability topics. Very important topics to consider in the context of scaling spatial digital twins. Also, data sharing principles and requirements need attention. Access to the right level of data, the right quality of data at the right time is critical to develop and maintain valuable digital twins. We've also seen of late that public authorities are increasingly investing in digital twin initiatives. And they do that at various levels of granularity, be it a municipality, be it a province, be it a county, be it a state, and in multiple application areas. So bundling the private sector expertise and bundling these with investments in the public sector in the form of PPPs will definitely play an important role as well in further funding and creating synergies between all these initiatives. The study also touches on the socioeconomic returns and the viability of investments in spatial digital twins, but it does that at a very high level. We agreed that a more in-depth socioeconomic analysis of the value contribution of spatial digital twins would require much more extensive research, and that's outside of the scope of this policy paper. Next slide, please. So before handing over to Thomas for a detailed overview of the key findings and recommendations, I would like to encourage all of you to download the report. You can use the QR code on the screen. You can also go to the WGIC website. Thomas will definitely also show the QR code again at the end of his session. So I would now like to hand over to Thomas Werner. He's the head of professional services and strategy in Integris Group Services based in Melbourne, Australia. And he will explain more about the research. Over to you, Thomas.
Thank you very much, Arnout. And I'd just like to thank everybody for the opportunity to present this overview. I know that Arnout mentioned that it's a detailed overview. I think we're going to spend probably 20, 25 minutes, something like that, talking through it. So I'm not sure how detailed we will get to it, but I really look forward to the opportunity to present to you today. So as Arnout mentioned, my name's Thomas, and I'm a management consultant from a Melbourne-based firm called Integris Group Services in Australia. One of our specialisations as a business is in asset management and in advisory, and it's been an absolute pleasure to support WGIC in the development of this report. With the wealth of information available out in the world now on digital twins, our aim has really been in this report to synthesize and structure the research, investigations, and analysis around three key value-based questions. Considering the varying factors and inputs into the policy requirements for digital twins, this report really has aimed to identify the value and the potential value of spatial data contributing in digital twins, answered by investigating the following three questions. What does socioeconomic value does spatial data add in digital twins? Which digital twin use cases could add value if they held spatial data or more spatial data? And thirdly, what does the geospatial industry globally need to embrace so that our services continue to add and demonstrate value? The research conducted in this study included global market scans, high-level analysis, interviews, and online engagement with subject matter experts. And as we'll step through shortly, it also looked to develop a future vision for spatial digital twins, which was validated with subject matter experts. And we even went to the effort of identifying an example of these currently in place or under development. We've done an assessment of the current state across the digital twin value chain and looked for the key actions as called for by subject matter experts or needed to help achieve the future vision through a policy lens as well as through a geospatial industry lens. As Barb and Arnout mentioned, we've been able to engage with over 60 subject matter experts across the globe to obtain insights and feedback. And I think that additional acknowledgement of the support provided by some of those subject matter experts was through interviews that we use to better understand the use cases that were being applied in industry right now, the applications and services being provided in the digital twin space, as well as to validate some of the key areas of interest and some of the findings that we're stepping through in the report, just to validate and make sure that everything seems to be covered and in alignment with what industry are actually finding right now. The third thing that we tried to do and extract out or synthesize in the report was to obtain inputs directly from industry for opportunity areas for policy, as well as the support that's needed for industry and by industry for effective development of spatial digital twins. Now, this point, we are talking a lot about spatial digital twins. I understand that, but this investigation and the analysis also included digital twins more broadly as well to try and put things in context. So we're going to step through a few things now, but before we do that, I'm just going to switch gears and build on some of the content just to set the scene a little bit more about where digital twins are right now from a technological development stage and kind of set the scene on some of the challenges that Barb alluded to earlier. So I think what we're now seeing is that the concept of digital twins has passed the peak on the Gartner hype cycle. I know some of you may have seen the hype cycle before, but to just expand a little bit more on it for context, the hype cycle tracks the progress of technology through a series of phases. I'll just step through that now, the laser pointer. The inception of the new technology, which then promises the world, fails to deliver, and then over time, it transitions through persistence in use and adoption until it reaches a state of normalization. What I like to think of with this hype cycle is that it's effectively something that's split in two, where there's a technological push on the left-hand side, where the digital twins effectively have started their life in manufacturing and in aerospace industry to serve a specific need. And now they're starting to eventually get into the applications pull area, which is separated by the peak in the curve or the trough, depending on your view or perspective. And what we're starting to see now is that these applications pull are starting to transition digital twins out of the factory and into the streets. As demonstrated from prior examples of tech implementations as well, more value is actually derived on this right-hand side through the applications pull process than was available through the technological push applications. And the biggest aim right now is to minimize the amount of time that digital twins sit in this trough of disillusionment, as it's called. I think over the next few slides, you're going to see that geospatial data definitely has a key role to play in minimizing the amount of time that we sit in this trough, and we can start getting normalized as quickly as possible. So what is a spatial digital twin? Well, the way that we've looked at that is to build on the current definitions that are available on digital twins. And I'll just like to talk a little bit about that now, that a digital twin is more than a 3D model or a simulation. It is an evolving virtual representation of an object or process that uses data from and observations of its physical counterpart. It's a dynamic digital replica of a physical object, process, or system that provides up to real-time status and performance monitoring from sensors and observations, all aiming to aid decision-making processes, planning, and predictive capabilities. So whilst digital twins are promoted as an approach or method that aids in decision-making, we can see that through incorporating two key aspects into those digital twins, which are spatial positioning attributes and dimensional accuracy of the models that are used for the visualization, they can effectively become spatial digital twins. And importantly, spatial digital twins can refer to more than just the built environment, and they can exist at various levels of accuracy, detail, and aggregation. Although they're used for planning and lifecycle management and smart cities and similar contexts, they can also be applied in broader domains. And I think that the important benefit that comes from them is not only the visualization, which is the main point that most organizations promote the whole benefits of spatial data, but it also enhances that scalability. We've seen it through the discussion in the Gartner hype cycle. We'll also see a few other points of evidence to support that statement, that the spatial data, dimensional accuracy, it unlocks additional use cases and improves the usability of spatial digital twins beyond the primary use case that they may have initially been developed for. So as the first component of the report findings, which supports the definition of spatial digital twins, what we found was that all use cases researched, particularly those with advanced use case requirements, have a strong reliance on spatial data. This includes things like the metaverse or virtual reality, augmented reality, smart cities, or smart infrastructure as applications. Additionally, geospatial data is fundamental for unlocking more applications from existing or individual digital twin ecosystems. And I think that this is a really important point. So building on that whole point about visualization, which is still a strong benefit for spatial data within the digital twin ecosystem, the capture services provided by our industry can also provide lower cost alternatives to having to develop comprehensive models using reality capture or other innovative solutions. We explore those in the report, and if we have time, I'll present them a little bit later in this webinar. But these three findings really bolster the value added by spatial data in the digital twin ecosystem. So moving now into other key components and findings of the report, I'm going to present the future vision that we see for digital twins and spatial digital twins. So if you can imagine a not too distant future, information underpinned by spatial data is shared across digital twins. So every digital twin can be aggregated or connected to inform, uplift, and influence stakeholders and digital twins around them. In this future state, digital twins can be connected into a global ecosystem, just like the physical world, so that data from individual and aggregated digital twins can be used to forecast, measure, and realize opportunities that drive socio-economic and environmental improvements. Each spatial digital twin on the planet, when combined through their physical location and context, create a true reflection of the Earth that continuously evolves through data and inputs, enabling forecasting on a global, regional, and site-specific level. Asset owners, policymakers in the public sector, defence, decision makers, and citizens more broadly can access this ecosystem, navigate to their area of interest, and access information that is continuously maintained, updated, and upgraded at the right level of detail for their use. Now, whilst this future vision may seem a little bit far-fetched, we've actually found in place now that there are demonstrations of use cases that are elaborated in the report. There's over 8 examples in there, but just to call some out, the National Digital Twin Initiative in the UK, there's an emergency management use case for digital twins within New Zealand, the Smart Nation in Singapore, Germany is looking to do interfaces between digital twins already. There's the Destiny, which is Destination Earth, and Ditto, which is the digital twins of the oceans. All of these examples are actually really becoming or have this future vision in alignment with where we're going. So the future is not too far away for this for the spatial digital twins. And I think that that's a really important point to look for, because it's key to get everybody aligned behind a future vision, and that was something that has been presented in this in this report that everybody hopefully aligns with and can get alignment with. So now, looking at where we are in the current state, whilst the not too distant future isn't too far away, we found that there's 5 areas or things that really need to be in place in order to be able to achieve the future vision. Whilst the report goes into detail about the current state across all 5 areas, in this section of the webinar, we're just going to touch on 2 areas, which is number 1, the standards, definitions, and current technologies align and communicate with each other. And number 3, the use cases solve organizational problems or demonstrate public benefit. So as Anne mentioned earlier, WGIC will be also available to discuss more of this during the virtual networking session after these presentations. So please feel free to come along and find out a bit more. So now, going through the current state assessment with the standards section, I think that it's critical that collaboration, connectivity, and communication across people, assets, and systems and applications is underpinned by good standards. To enable the future vision, standards need to be flexible enough to apply in multiple contexts, as well as rigid enough to enforce data transfer and information exchange in meaningful formats. I know that sounds easy to say, but the implementability of something like that, I think, has been, I'm sure we're going to find out a little bit more about that. Look, when we did the research into the approaches used by industry standards, we found that there's generally 2 approaches that are developed, both of which evolved through iterative and consultative approaches, typically over a longer or medium to long-term horizon. So the approach 1 is a structured approach that follows 4 key steps of defining what the meaning of the words and terminology means, identifying all the possible use cases, establishing the frameworks that fit and apply to those use cases, and then defining the exchange protocols. The other way was a collaborative and user demand-driven approach that prioritizes the establishment of interest in data exchange and information sharing first, before normalizing on the use cases, frameworks, definitions, and data formats and standards. What was also apparent from the research was that there's multiple organizations working on standards for digital twins and spatial digital twins. And during the early years of new technology development, it's found that technology providers have had to establish their own ecosystems and frameworks in isolation, or establish partnerships whilst the standards are being developed or finalised and progressed, which can have an impact on wider adoption. And whilst these challenges are all in place, what we still found was that there's a large majority of people are very passionate about the importance of standards in place for everyone. The other bit that we found from research and engagement with subject matter experts was that location attributes, such as the spatial position of a digital twin, could be used as a primary integrator within standards attribute frameworks. And I think that integration by place is a really good opportunity for unique identifiers, because no two things can be exactly in the same spot technically, but I hope you guys understand where I'm coming from with that. And then thirdly, when governments have actually gone in with policy of backing a particular standard or group of standards, or provide some form of direction, it's actually instilled confidence in industry to invest, as well as everybody kind of has this North Star. Once again, it's the whole theory of setting a future vision that everybody can be connected with, and then it allows for development in that space. So we're coming close to finish now on the slides that I planned on presenting before we break into questions. But look, the other aspect that we wanted to present was that we found 27 use cases for digital twins right now, linked to various business or organizational needs or business problems. And almost all of these use cases leverage or utilize spatial data, whether it be dimensional accuracy or spatial positioning in some way. So if we plot the use cases across the typical level of spatial positioning attributes or dimensional accuracy, which is what the X and Y axes of these ones are, you can see that there's 4 tiers of use cases as shown by the banded rings as tier 1, tier 2, tier 3, and tier 4. Because we were quite interested in the use cases where value could be added by spatial data, we focused our efforts and investigation on tiers 3 and 4, where sometimes spatial attributes are available, but they could potentially add value through visualization, scale, or other means with the use of spatial data. But one thing that we also found was that for each of these use cases, there was at least one identifiable business problem, and or the digital twin solution met an identified organizational need. So when we did the research and engagement with subject matter experts, 6 key focus areas for where the geospatial industry can continue to demonstrate or add value were identified. We go through all 6 in the report, but I'm just going to focus on the top left and the bottom right points of this one. It's great and exciting to obtain new technologies, and as a geospatial engineer, I completely align with that, getting the latest equipment and gear to be able to improve ways of working. But by doing so, sometimes you actually create problems upstream or downstream from you within the ecosystem or across the value chain, and it can have impacts on wider stakeholders. So I kind of call that the bleeding edge, where you're sitting on the leading edge so far that you're actually starting to create more problems and entering what's called the bleeding edge. And I think that by considering all stakeholders and aligning things with requirements and technological specifications of what clients actually need for importing data, particularly data into their systems, I think that that's a very important point to consider. And additionally, embracing the fact that the opportunity space is moving fast, and I think that whilst it may seem far-fetched and a distant opportunity, the sooner that we all band together and have preparations and development for trying to achieve the future vision, the sooner it will be achieved, and the sooner we'll get through that trough of disillusionment. So finally, when subject matter experts were asked to identify opportunities and gaps in existing policy, there was an overwhelming response for ensuring that simple things are adopted and enforced by relevant stakeholders. So the key themes that came out we saw were collaboration, communication, skills, or innovation, but they really can't be understated in their importance. I think if these simple things are put in place, what will happen is the advanced things will become possible. And when the advanced things become possible, the future vision can be achieved. So that this slide will keep up for a few moments for those of you who would like to download the report or download it from wgiccouncil.org. And I would like to once again thank you, the WGIC Policy Committee, Barbara Ryan, and the asset mapping events for the opportunity to present today. Thank you.
Thomas, thanks so much. And Arnout, I'll ask you to come back on camera too. And then I hope everybody's got that QR code, because Thomas, I'll ask you to stop sharing your screen, and then I'll be able to see you and Arnout if you want to weigh in on some of the questions that were being asked. So great. Very good. Listen, thanks for that presentation. I really appreciate it. And listen, I've got a couple questions, but we also had a couple from the audience that came in. So maybe you saw it. Sujit Samadar asked about the application of digital twins to large office complexes. And Thomas, I thought maybe in some of your interviews, you might be able to talk about that, or even the work that Bentley is doing at Griffin University. I understand that's in your neck of the woods. But before you do that, I guess I'd like to just say one thing, and that's not just to Shajit, but maybe to everyone. For me, when I think about this entire metaverse, whether we're doing a digital twin of the desk I'm sitting at, or my room, or the house, the county, the town, the state, or the globe. I mean, I think the vision that we're trying to advance, particularly through standards and integrated data, is it would be wonderful if these digital twins could in fact be integrated in a much more coherent way. So the three levels that Thomas has articulated, whether it's kind of a mini level or maybe something of much smaller scale, smaller areas, something in the middle, more hybrid, and then of course very large regional, national, or global for metaverse scales. I mean, that's where we'd ultimately like to go. But Thomas, I'll stop, go back on mute, and let you answer the specific question about large office complexes.
So I didn't actually get a chance to see or read the specific question, but in terms of use cases with that, I think I'd like to pivot to one where I think it kind of highlights some of the similar challenges or similar benefits and opportunities. So the emergency management example that we got from the City of Wellington in New Zealand, that there's effectively a requirement of all buildings, even private buildings, to have motion sensors because of the vibrations that Wellington's basically on an earthquake, like it's a highly active earthquake zone. And once upon a time, when an earthquake over, I think, the Richter scale of 7 happened, there need to be inspections of every single building to make sure that it was safe before people could be brought back in. Because they brought these sensors in, effectively the council in New Zealand have their sensors that are always available and always on to them, being able to be used in that space. But there's also a requirement on all of the buildings within that space or within the city to provide the motion sensor data from their buildings in to that digital twin, so they can kind of highlight and identify opportunities for minimizing the amount of inspections that need to happen based on the amount of vibration that was in that area. And I think that example in itself kind of provides the benefit that if you are able to aggregate and if you are able to scale things, it can make things, it can unlock new use cases. And I'm sorry, I don't have the specifics to the question, but I hope that kind of points out that there are use cases out there and new ones are being found, through the use of spatial data and geospatial data.
All right, thanks, Thomas. Let's see, a couple things. There are some questions about recordings and slides being available. Certainly the entire recording, Anne will let you know about that. It can go back to Connect Me for that, and also the slides. And then of course, the slides that Thomas, Arnout, or I presented are also widely available. So just write to us on our website if you would like those slides. And then also there is a note here. I don't know, we are getting some questions and we are responding to some of them online. I'm just not, I think they're going to the Q&A, so everybody should see those questions. But if for some reason they're just going to the chat, we'll do a double check on that. Let's see, let me just ask this. And Arnout, this could be for you as well as for Thomas. What areas for further investigation? It's actually a little discouraging when we look at that Gartner hype curve to see that maybe we haven't hit the trough, the bottom of the trough yet, and hopefully we're going to be on our way back up. But any other research areas or things that the community or the industry could be doing that would maybe help us get up there a little bit faster? And for either one of you.
Arnout, you happy if I take this one and you add to it? Yeah, sure. So
yeah.
Look, there were a few areas identified in the report as well for opportunities for further research. A couple of them to touch on really is to quantify that economic benefits of spatial data. That's the one that Arnout kind of highlighted, and although it was out of scope, we have done a bit of a high level assessment of socioeconomic factors as well. The investigation that we did was very much user or service provider focused as well. So the engagement that we did and the interviews that were done were by providers of solutions in this space. That we really appreciate the perspectives of everybody's input, but we also did ask them what their clients are saying and what they're thinking about. But there would or could be an opportunity to actually go and speak with particular clients, whether that be, large organizations that are actually investing in it, venture capitalists that are now investing in digital twins, governments that are investing in test cases and in digital twins, to kind of get both sides of the coin. I think that would be a really strong opportunity. One more, and sorry, Arnout, this might be pinching a little bit from your thunder, but flipping the notion that technology is king to sustained interoperability is king. I think it was very common in the presentations or in the interviews that we had with people that technology is king is basically where everybody is coming from. But as I sort of mentioned in that bleeding edge aspect, if there's a transition of the thinking in the geospatial industry from technology is king to sustained interoperability is king, then I think that some of those communication barriers will break down. And additional opportunities will arise through collaboration with other industries as well.
Okay. Arnout, I'm going to jump in on this because the questions are coming fast and furious. I'll let you respond if you had views of what Thomas just said, but there is another one that I think you're in a really good position to answer. It's from Dominique Crotu. How to reconcile the high rate of physical change in the world and the quality control of data in geospatial digital twins, considering the time it takes for data acquisition, integration, quality assessment. I mean, I can only imagine that TomTom deals with this all the time. I'll stop there.
Yeah, thanks, Barb. This is indeed a very important challenge, and I will also try to make the bridge to the earlier discussion of and responses by Thomas. So indeed, I think it's key that for whatever reason the slide always switches off here. It's also technology. So to keep a spatial digital twin in sync with the physical world is indeed a challenge, and especially if you apply kind of a waterfall process of data acquisition and then integration of those data, quality validation, deployment, that can really take quite some time. But at the same time, what we see is that in recent times with let's say a more data availability of let's say big data, large data, but also real-time data, like for example, sensor-based data, crowdsourced data. It's definitely, it's enabler for more, let's say, close to real-time maintenance of digital models as well. Certainly, if you combine that with AI/ML-based technology, if you combine that with powerful fusion methodologies, and also if you combine that with more of a transactional capability to keep the digital model up to date, you can really shorten that time to reality cycle quite a lot. So that's in my view certainly the evolution that I see in the space I'm working in. So the navigation and high definition maps, where we evolved from quarterly release cycles to monthly, weekly, and now we're talking about daily releases of updates. So we really see that happening, and that's only possible because we get all this access to, for example, car sensor data. We get access to floating car data and crowdsourced data. So those are really the, let's say, what we call super sources to keep our digital models up to date. And maybe to make the bridge to what Thomas mentioned earlier on where I see a need for additional research and investigations is to really understand how the more shared access to these super sources could actually help to drive let's say further collaboration, interoperability, and so on across different actors in the ecosystem. So I think that data sharing models are, in my view, key for future success of cost-efficient maintenance of digital twins across multiple domains and multiple actors.
Thanks, Arnout. So we've got a question that from Jeff Zeiss that actually builds on something you alluded to, Thomas Wellington's digital twin work, and it's both above and below ground digital twins for both. And of course, Jeff is arguing that there are tremendous benefits from, you know, us being able to do that below ground, and he's exerted a lot of leadership for that in Canada. But are you seeing subsurface digital twins as a significant opportunity in the spatial digital twin arena? Did you hear that through any of the interviews? Thanks.
Yeah, so that's a really interesting one. So there was actually a professor from a technical university in Bochum in Germany who was actually looking at doing a digital twin of an underground mine and modeling that. I know that that's kind of a little bit parallel to the underground subsurface utilities that you're referring to, but it's very tangential to this. And interestingly enough, used GIS to actually integrate the 3D building information modeling data that they had access to for the above ground surface, the terrain model that they were able to get freely available online, as well as all of the information that they were able to measure and then put sensors in. So there are use cases and applications for it. We didn't hear too much about it through research. However, I also do know that there's been a large drive for that, and particularly within the building information modelling aspects of it, the underground services have been mapped quite heavily, particularly in the UK, and there are efforts for that. But I see that there are opportunities to actually use that modelling data from building information modelling or from capture of networks and things like that, either represented visually through a geospatial information or geographic information system or some other visualization to actually use for monitoring flow rates and things like that for digital twins. There have been a few of those kinds of opportunities done, particularly in the electricity, but that's above ground utilities sector. I didn't hear too much about digital twins underground in the utility space, but definitely the modelling side of things, because obviously they're static objects, they shouldn't really move too much. So I hope that helps answer the question. You're on mute, Bob.
Thanks. Sorry, I know we're running a little bit short on time, but Joshua Lieberman's got a couple questions. One is what digital twin is not fundamentally spatial? I might have jumped in and said, well, it's kind of a motorcycle. A digital twin of a motorcycle is a little bit different than what we're trying to propose here. But I think that leads into actually one of his other questions, which maybe pushes us farther, which is how much of the digital twin value comes from a capability to simulate what is not or not yet there or not yet existing. And so I can think about landscape change and simulating or modeling that change. And is that where we've got to bring kind of IML into the whole situation? But we'll let you answer, Thomas and or
well, that's a really curly question, and I like it. So what one way of thinking about digital twins is or the value that you can derive from digital twins is whether or not the asset in its base state versus its optimum performing state, what the gap is between those two things, to be able to monitor, measure, maintain, make sure that it's ready. So to explain that, let's just imagine a warship as an example. Whilst it's floating around on the sea, just doing transit, it doesn't need to be armed and ready and ready to fight. However, at the same time, if something were to happen and there was an incident that required it, it would need to perform at a peak level very quickly, and basically everything gets turned on and ready to go. So digital twins can help simulate that and predict the capability of the asset to operate at that peak performance level. The difference between that and, for example, a building is that a building is a building. It's not going to change in its peak performance one way or another. It will obviously erode and degrade over time. So I think to try and bring that explanation back to the key question, there are opportunities to try and measure the value from the performance of digital twins, but it's not going to be for every single use case. And really, this kind of comes back to an exploration to work out where those use cases are going to benefit, and as opposed to saying, well, we can measure everything now because we've got digital twins, which is the whole technological push notion from the traditional kind of manufacturing and aerospace side of things, looking at the applications pull and saying, well, what value do we need to draw? And if we had a digital twin, would that help us measure how we get there? And I think that's the important point to raise from the research that we've done.
Arnout, I saw you nodding your head at one point. Was there anything you wanted to add to that?
Sorry, no, not specifically. I was just thinking of another example in my space or my domain around highway load prediction, which could be something where you basically can use let's say a digital twin of a certain design of a highway and predict future loads and predict whether the current design would actually deal with future traffic loads at peak time. So that's another example where you actually look at similar to the warship example of Thomas, basically. But just one in my domain.
Okay. Okay, listen, thank you both very much. You're certainly welcome to reach out to either one of these people with additional questions. You can also come to the networking session at the end and talk to them virtually through that platform. I know there are a couple other questions about standards and then about terminology with digital twins and smart cities. I think all of those are going to be handled in the next session, and so we will do. Well, let me just say one thing about that smart cities reference, though. I think you saw in one of either Arnaut's slides or Thomas's about just multiple terminologies, and again, our ability to communicate this whole field outside. And I think for me, they're the same, but it's an issue of communication. But we'll see what Peter has to say in the next presentation. So Arnaut, Thomas, thank you very much.